Hey everybody! Today we're going to deep dive into the points node. I just wanted to point out first that Blender 4.4 is now available. It comes with a ton of bug fixes and a couple new geometry nodes too. I'd encourage you to check out the What's New page on the blender.org site if you're curious. As I mentioned, today we are going to look at the points node. We'll discuss all of the inputs and look at a few different ways we can use the output points. Let's head over to the Geometry Nodes workspace. I'm going to make the viewer window a little larger so we can see what's going on. And let's add a new Geometry Nodes modifier. We can delete our group input node. And let's go ahead and bring in a points node. Next, we'll hook that up to our output. And we can see a single point on the origin. The first input of the node is count. Let's go ahead and bump this up so we can have more than one point available. If we zoom out, we still only see 1 point. Shouldn't we see 5? Well, there are actually 5 points present, but they are all being created at the same location. If we look at the next input, position, we can see that they are all being created at 0, 0, 0, as indicated by the position input default. If we move any of these position values, we only move the location where all of the points are created, and they still all occur together. We'll discuss ways to distribute our points in just a moment. Let's first reset them back to the origin, and then take a quick look at radius. We can see with radius that we can scale the size of our radius, and we'll see some examples soon of how this can affect our end product. Let's set this back to 0.1 meter, the default, for now. So let's bring in a random value. We'll change the type of random value to vector, and then we'll plug this into the position socket. This will create a different pseudo-random vertex for each of our points. And if we zoom out, we can now see each of our 5 points located randomly between the 0 and 1 values of each axis. If we change the values in our random value node, we can increase the space between our points. Let's increase our count more to add some additional points. So what can we do for a more ordered location for our points? Let's go ahead and bring in an index node. The index values for our points will be an integer value incremented by 1 for each point. We're also going to bring in a combine XYZ node. Let's bring our index value into the z-axis value for our combine XYZ. Now let's bring this value into our position socket. Now when we zoom out, we can see that our points are placed in 1 meter increments along the z-axis. If we bring this into the y-axis instead, we can see our points laid out along the y-axis, again in 1 meter increments. Similarly, we can use this value for the x-axis to have our points along the x-axis. We can also use it in multiple axes, and we can see that we are now placing our points along both the z and x axes. Let's also bring in a math node so we can scale this increment with multiplication. This will default to a multiplier of 0.5, so we can see our increments cut in half. We can scale this up and down as needed. So let's add a point to curves node. Let's also add a curve to mesh node, and we'll add a curved circle for our profile curve. We can adjust the radius of our curved circle to make the mesh smaller or larger. Let's also look at the radius of our points node. We can see that increasing that also increases the size of our mesh. Let's bring in another random value node. We'll leave this as a floating point number and plug this into our radius socket on the points node. And this gives us a very interesting shape. Now let's move our curve and mesh nodes out of the way. Let's bring in an instance on points node and move these a little bit more out of the way. We'll go ahead and bring in an icosphere for our instance. Let's scale down the icosphere's radius so our icospheres aren't intersecting. We'll also bump up our subdivisions to 3. Let's go ahead and bring in a transform geometry node so we can do a bit of animation. We'll go to frame 0 and keyframe our rotation using the I key. Now let's go to our last frame, increment our Z rotation value to 360, and keyframe that as well. And we can see that our instances are all moving together around the origin. And of course, we can animate any of these values: translation, rotation, and scale. Now we're going to bring back in the nodes we removed earlier. We'll bring our points back into the points to curves node, and then we'll plug the curve to mesh node into our instances on points node. Now we are placing an icosphere on every point of the curved circle that surrounds our points. Since our curved circle has a resolution of 32, we now have 32 icospheres for each of our points in a circular pattern. Let's bring down the size of our icosphere once more to give them a little bit of breathing room. Note also that we can scale the max size of our circles of the instances by reducing the max value in the random value that controls the radius of the points. Let's take a look at animating our individual icospheres. We'll bring in a set position node. We'll also add a noise texture, and let's bring the color into the offset socket. Let's bring the radius for our curved circle up a bit more to spread our instances out. Now let's change our noise texture to 4D so we can add some animation here. Let's go back to frame 0 and keyframe the W value at 0. Now let's move to the end frame and set the W to maybe 2. and keyframe that as well. And if we play the animation, we can see our icospheres moving a bit. We still have our Z rotation animation, so let's stop our animation, return to frame 0, and clear the keyframes for rotation here. Now let's go ahead and bring in a vector math node. We'll place this between our noise texture and the offset of the set position node. Let's update the operator to multiply. And we can see as we scale it up that our icospheres are more diffused or spread out. And if we play our animation, we can see greater movement of our icospheres. Next, we're going to look at something a little different. Let's go ahead and add an empty to our scene. Now we're going to bring in a grid. And let's update that to 20 by 20 meters and set our vertices to 18 by 18. Let's separate our output from our previous setup and bring in our grid. Now we'll add an instance on points node and use a cube for the instances. And we now have a grid full of cubes. Let's grab our empty and drag this into our geometry node setup. Next, we're going to add our points node. We're going to grab the location of our empty and bring it into the position of our point. We only need one point for this particular application, and this basically serves as the physical representation of the empty. Next, we're going to add a geometry proximity node, which will allow us to essentially measure the distance from our empty to our instances on the grid. We'll plug our point in as the geometry. Let's set the target element to points. We're also going to bring in a map range so we can adjust the area we are going to affect. And we'll bring the distance into the value socket. Let's move our instance on points node over a bit. And then let's bring the result of our map range into the scale socket of our instance on points node. You can immediately see that the inner squares are scaled down slightly, where the distance is less than 1 meter from our empty. Let's adjust the from max up to increase the area of cubes affected. What this is saying is that the cubes that are at or beyond our max value will be scaled at 1 or full size. And anything closer than the from max will be scaled in relation to its distance, the values between 0 and 1. Therefore, those cubes will be at a fraction of the full size in somewhat of a gradient. If we increase our toMin value, that will be the minimum fraction of our whole cube that we will scale to. By bumping it up, nothing will scale to 0 and be completely removed from the scene. Similarly, if we bump up the toMax, we will see the cubes outside of our from max distance scale up above full size. So now, if we grab our empty and move it around on the X and Y axes, we can see the scaling of our cubes following it. We can go ahead and pin our Geometry Nodes modifier so we don't lose it when we select our empty. Let's go ahead and add a quick material for our cubes. We'll come over to the shading workspace. Let's go ahead and select our cubes since we can't create a material on an empty. Let's bring our color to a medium gray, turn up the metallic, and turn down the roughness a little. We can name our material Silver. If we come back to our Geometry Nodes workspace, we can add a Set Material node and assign our silver color. Let's switch the viewport to Rendered mode. That default light looks really harsh. Let's go ahead and remove that one, and we'll add an area light. Let's bring it up on the Z-axis and then scale it. We'll come over to the light's object data properties and we'll set it to 2000 watts and change the color to a slightly blue shade. And that looks a lot better. Let's adjust our camera. I also want to darken the background for my render. I'll adjust the world setting in the shader editor. Now let's render a still. And that's going to wrap it up for this quick little video on the points node. If there are any other nodes you'd like to see in detail, just let me know in the comments section. I hope you have found this video useful and informative. Please like and subscribe to help support my channel. Have a great day, and I wish you all a very happy blendering.